Okay, so here we are, day 4 of factoring, and this is where factoring starts to get a little tricky. I know it's a lot to remember, what with how to factor things in standard form. We practice factoring differences of squares, and today we're going to factor polynomials by grouping. The good news is that this is the last new technique you're going to have to master. Once you've learned how to factor by grouping, you've really learned everything that there is in Algebra 1 about factoring. We'll be ready to kind of move on to something different. So let's talk about this. What does it mean to group terms? Well, what is it, in other words, factor by grouping? Well, it means to arrange polynomials, or to rearrange, so that common factors can be found and factored out. And so we're going to work through a bunch of examples here that show this. And it says factor each expression, grouping terms as necessary. Emphasis on the word grouping. Now, for example 1, there's nothing to group here. This is 3x squared plus 12x. I'm looking to factor it. And I'm just asking myself, okay, well, what are the common factors here? What's common between 3x squared and 12x? Well, 3 is common, right? Because 3 and 12 are both divisible by 3. And you'll notice that they also both contain an x. This has 2 powers of x. This has 1. So I can factor out 1x. And that leaves me with 3x times x plus 4. All right, so we've gone ahead and factored that one. There's nothing left in the parentheses that I can factor out. And that's just to sort of demonstrate here what we're looking for when we're factoring. We're always looking for common terms, common factors that we can divide out of terms. Now, for example 2, this gets into the grouping idea here. I have 4xy plus 7 plus 2x. Well, when I look at all 3 of these, there are no common factors. Not common to all 3 of them. Anyway, so 4xy and 7 have no common factors. None of these coefficients are divisible by 7. And 7 contains no variables, so there's no common variable to all 3. But what I can do is I can group this. So I can say, you know what? I'm going to rearrange this. I'm going to write 4xy plus 2x plus 7. And then I'm only going to factor what's here. I'll just put parentheses around it so you can see it. So what this really does, there are 2 parts here I can factor, right? 4xy and 2x do have common factors. So if I look at this and say, okay, well, what's common to these? Well, I can factor out a 2x. They're both divisible by 2. There's 2 x's. I factor out the 2x. And then I'm left with 2y plus 1. And then I have the plus 7 here. Now you can't go and simplify this any further. Don't go try adding the 1 and the 7. This 1 is trapped inside the parentheses and it's part of this product. But you can see here that we did factor it somewhat just by grouping these terms and then factoring out the 2x. Okay, same drill here with this next one. We have 2a minus 3b minus 4a plus 6b. Now the way it's written, there's obviously no factors common to all 4 terms. And I do have a couple a terms here, and I have a couple b terms here. So let's group those. Let's see what we get here. So I'll take the 2a and the negative 4a, and all I'm doing is just reordering this polynomial. Remember, you can write polynomials any order that you want, so long as the sign in front of each term stays the same. So I'll write 2a minus 4a minus 3b plus 6b. And then what I'm going to do is I'm going to factor these into groups. So I'm going to factor this group, and then I'm going to factor this group, right? Okay, and that's going to leave me with, okay, well, 2a minus 4a. I can factor out a 2a there. So I have 2a times, okay, and then what's left here? Well, it's just going to be 1 minus 2. And then over here, I have negative 3, and well, I can factor out a 3b here, it looks like, a positive 3b, so I'll write plus 3. We typically factor out positives, so I'll factor out the 3b. And what am I left with in there? Well, I have negative 1, and I have plus, 2? Negative 1 plus 2. So I could simplify a little bit further if I wanted, but you don't really need to. There's nothing else we can do with this. We can't factor this any further here. Otherwise, we'd just be combining like terms. But it just kind of demonstrates how to group similar terms together and then factor them from there. Now, we can take this a step further, and this is where it starts to get a little tricky. We can't just limit ourselves to factoring out coefficients and variables. Sometimes we can factor out entire expressions. So we're going to look at this example 4 here. It demonstrates this pretty well. It says to factor this expression, I have a times a minus 2 plus 3 times a minus 2. Now, it doesn't help to try and distribute these, right? Because if I distribute these, I'm going to get a squared 3a, and then we're trying to factor. So don't do any multiplying, because multiplying is the opposite of factoring. But if you look closely here, if I treat these as 2 separate terms, so here's the plus sign. If I treat this as an entire term, which I can because it's a product, and if I treat this as an entire term, what's common to both of them? You'll notice that the entire binomial a minus 2 appears in both terms, right? I can factor that out. So, in a sense, I'm basically dividing it out. That's what we do when we factor, is we divide it out. And what that's going to look like in my answer is I'm going to take out that a minus 2. I've divided it out, so there's a minus 2. And these are gone. And then just look at what's left. Well, I have the a still here, the 3 still here, so I just write that as the other factor, a plus 3. So this expression in factored form is just a minus 2 times a plus 3. That's a little tricky, so let's look at another one here. Okay, well, I have p times q plus 1 minus 4 times q plus 1. Once again, we see that there's this term here. We look at this as one term. We look at this as another term. And I ask myself, what's common? Well, they both have q plus 1 as a common factor. So I factor out the q plus 1. Q plus 1. Now that's gone, right? So just ask yourself what remains. What's the other factor here? Well, the remnants of this, so to speak, are p and negative 4. So that's going to be q plus 1 times p minus 4. There's your answer there. Okay, here's another one like this, right? Okay, so they're already grouped for us here. That's kind of common to all of these. And now just ask yourself, look at this here on the left, look at this here on the right. What is the common factor? What can I divide out of both of them? Well, in this one, it's x plus y. And then in the other one, once I've factored this out, what's left? Well, there's still the positive 5 here. There's still the positive w. So my other factor is just 5 plus w. And then, finally here, this last one's a little tricky, just because there's one little thing that you might miss here. You're going to see pretty clearly that the common factor is m plus 4n. This binomial is common to both here, right? So I can divide out that. I have m times m plus 4n minus m plus 4n, right? So this gets factored out, and I just write that as m plus 4n. That's one of my factors. And then this is where you'll make the mistake, right? A lot of people will just write m. They'll just write m, close the parentheses because they see the m here, and there's nothing over here. Okay, that's it, we're done. Well, remember, there is something here. Ask yourself, what's hiding here, right? There's an m here, we got that. What number is here? Well, remember, there's always a 1, right? So this is actually, the answer for this one is going to be m plus 4n times m minus 1. And for sake of argument, if this were a plus sign instead of a minus sign, we would just write m plus 1. But just don't forget about those phantom 1s. They do hide in there, and they do need to be included as part of your answer. Okay, so there you have it. That's most of what you need to know when it comes to factoring by grouping. There are a couple of tougher problems that we'll look at together when I get back from vacation, but that'll be better if we look at those just, together. Anyway, good luck with this. I hope it's helpful, and I'll talk to you soon.